alkyl groups. By now you know alkenes, they are saturated hydrocarbons, and obviously they are aliphatic hydrocarbons, and they can be classified as hydrocarbons simply because they contain carbons and hydrogens. This table that I have right here mentions the homologous series for alkenes, meaning if you go down the table you can see that the carbon number increases, and over here I have just mentioned the names and the related data for alkanes containing up to 10 carbon atoms. If you have an alkane that contains 1 carbon atom, you call it methane or methane. If it contains 2 carbon atoms, you call it ethane. 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, and 10 decane. So as you can see, the molecular formula also varies. So the number of carbon atoms increases from 1 to 10 down the table, and according to that the hydrogen number also changes. So alkanes have a general formula of CnH2n plus 2, meaning if you have n number of carbon atoms, the number of hydrogen atoms will be equal to 2n plus 2. So if you have 1 carbon atom, you will have 2 into 1 plus 2 number of hydrogen atoms. So if you have 5 carbon atoms, the number of hydrogen atoms that you will have in the formula or in the molecule of pentane would be C5H 2 into 5 plus 2, so 12 number of hydrogen atoms. So that's how the alkenes get their name and their molecular formula. Now, over here, what do I have on the right of the table, to the right side of the table? So that's when, if I take the alkane and remove 1 hydrogen atom from that particular alkane, I will get an alkyl group now. So it's no more an alkane, now it's an alkyl group. So when methane is converted to its particular alkyl group, the ane suffix now gets removed on its end, from the ending, and gets added with the suffix Yl, because now it's an alkyl group. So methane will be converted to methyl, and it no more has 4 hydrogen atoms. It is now consisting of 3 hydrogen atoms. And as you know, carbon needs 4 electrons in order to complete its outer electronic configuration with the already existing 4 electrons it has. Therefore, it needs 4 bonds around it, and when 1 hydrogen is removed and only 3 hydrogens in the case of methyl is existing, the extra bond will be represented by this particular dash that I have given here. So ethane will give you ethyl, propane will give you propyl, butane will give you butyl, pentane, pentyl, hexane, hexyl, heptane, heptyl, octane, octyl, nonane, nonyl, and decane, decyl. So all these that I have mentioned over here can be, on the alkyl side, can be named as R groups. So that is when the R group is an alkyl group. So let's say I prefer to take the hydrogen from the ending. So in the case of methane, CH4, it anyway has only 1 carbon atom. So I take the hydrogen from somewhere and I end up with CH3. So I have methyl. And from ethane, I take the hydrogen from either carbon because it has 2 carbons, and I end up with CH3, CH2 anyhow. But in the case of propyl, I have 2 possibilities, or actually 2 opportunities. One is taking the hydrogen from the end carbon or the starting carbon, or I can take a hydrogen from the middle carbon. So in that case, in the first case actually, where I take a hydrogen from the end carbon or the starting carbon, so that is the first carbon, I end up with propyl. But in the case where I take a hydrogen to make its own alkyl group, I take it from the middle carbon or the second carbon. I end up with isopropyl. So likewise, the name of the alkyl group will also change depending on which position the hydrogen is removed from. So anyhow, all of these and others, the rest of the ones that I had in the previous table, can be called as R groups. So this is the case when R groups are alkyl groups. But in the case where R groups are phenyl groups or benzyl groups, that is when they are aromatic. What does a phenyl group mean? It is when the benzene ring is attached to some group of atoms. So as you can see, these are some ways in which you can represent a phenyl or a phenyl group. So in that case, you have benzene, and one of the hydrogens of benzene is now removed, and this particular group is what's acting as the R group. The same thing can be represented with the Kekulé structure, but in this case one of the hydrogens is removed. Or in the case where you decide to show the molecular formula, so benzene is actually C6H6. Now it is no more H6, one hydrogen is removed, so you will have C6H5. Or to represent the phenyl group itself, you will have PH and a dash representing the bond. So at your stage, you do not need to know this representation and this representation, but it is good to have an idea as to the ways in which the phenyl group can be depicted in. On the other hand, you have a benzyl group. So benzyl group is when a phenyl group is attached to a methylene group as well. So methylene means, so if you can remember, methane means CH4, methyl means CH3. Now methylene means a CH2 group. So a CH2 group means you need to have two extra bonds in either side. So one of the bonds will be consisting of that phenyl group, and the other group will determine the functionality of this particular compound or of this particular molecule. So you have a benzyl group, which means a phenyl plus a methylene group together. So these are the ways in which you can represent the benzyl group as well.